The configuration of RIP, dynamic routing on the router. Let's first take a look at the objectives of this experiment. To understand the configuration method of the IP protocol. To learn how to view the routes learned and generated through the dynamic routing protocol RIP. And to be familiar with the connection method of campus network cables. Now, let's consider the hypothetical background of the experiment. We assume that the campus network is connected to the campus gateway router through a layer 3 switch, and the router is connected to another router outside the campus network. The goal is to configure the routers to enable communication between internal hosts in the campus network and external hosts outside the campus network. To simplify network management and maintenance, the school decides to implement communication using the RIP version 2 protocol. Now, let's understand the technical principles of IP. Firstly, the full name of IP is Routing Information Protocol. It is an early and widely used interior gateway protocol, IGP, used in small, homogeneous networks. And it is a distance vector routing protocol. There are two types of dynamic routing protocols: distance vector and link state. And it belongs to the category of distance vector routing protocols. In the IP protocol, hop count is used as the metric to measure the path, and the maximum hop count allowed is 15. The RIP protocol has two versions, version 1 and version 2. RIP version 1 is a classful routing protocol that does not support VLSM, variable length subnet mask. It uses broadcast for routing information updates, and the update period is 30 seconds. On the other hand, RIP version 2 is a classless routing protocol that supports VLSM, variable length subnet mask, and uses multicasting for routing updates. The steps of the experiment are as follows. Similar to before, we first construct the topology diagram according to our experiment guide. In this experiment, VLAN 10 and VLAN 20 are configured on the layer 3 switch. VLAN 10 is used to connect to the campus network segment, and VLAN 20 is used to connect to router 1, which is a router. The routers are connected via V35 cables, which are serial interface cables, with the DC end connected. The clock frequency of 64,000 is configured on the array. The experiment steps are as follows. 1. Connect hosts and switches using straight-through cables, and connect hosts to the router using crossover cables. 2. Erase, display and save configuration on the devices. 2. Configure RIP version 2 routing protocol on the S3560 layer 3 switch and IP version 2 routing protocol on router R1 and R2. 3. Set the default gateway of PC1 and PC2 hosts to the IP addresses of the network devices they are directly connected to. 4. Finally, verify if PC1 and PC2 hosts can communicate with each other. The equipment for the experiment includes two PCS, one layer 3 switch 3560, and two routers. Straight-through cables, crossover cables, and serial interface cables are also required. The topology diagram shows that PC1 is connected to the layer 3 switch, which is then connected to router R1. Router R1 is connected to router R2 via a serial interface, and router R2 is connected to PC2. To configure the RIP version 2 protocol, it needs to be configured on the layer 3 switch, R1 and R2. The following steps are simulated and configured on Packet Tracer. OK. Let's take a look at this RIP routing protocol experiment. First, according to the experiment guide, we need to build the topology. Now, let's observe the topology. In this topology, PCG belongs to the 192.168.2.0 network segment, and its gateway is 1.1. which should be on the VLAN 10 interface of our layer 3 switch. Right. Its default gateway is 1.1, and the interface facing router R1 is in VLAN 20. The other interfaces are related to the connection between R1 and R2 in the 192.168.4.0 network segment. PC1 is in the 192.168.2.0 network segment. Now, let's start configuring the port addresses of each device according to the requirements. First, we need to configure the layer 3 switch. Let's take a look. On the layer 3 switch, we need to set up the B class. So, first, we'll create the B class. Alright. Let's adjust the window to a suitable size. OK. Now let's proceed. First, we'll configure the device name for this switch. It's a Cisco 3560. Right. 3560. Great. After configuring that, we need to create VLAN 10 and VLAN 20 on it. After creating them, because it involves routing, we need to enable its routing functionality. After enabling the routing functionality, we can start configuring the addresses for its ports. First, we'll configure the VLAN 10 interface. The VLAN 10 interface is connected to the PCS and belongs to the 192.168.1.0 network segment. Right. So, its IP address should be 192.168.1.1 with a subnet mask of 255.255.255.0. OK. Now for VLAN 20. Can you confirm it? We enter the command int VLAN 20. Sure. Let's continue with the configuration of the interfaces on the devices. Let's start with the layer 3 switch. For VLAN 20, the interface address is configured as 192.168.3.1 with a subnet mask of 255.255.255.0. Now, let's move on to router R1. We need to configure its F0 zeroth interface with an IP address of 192.168.3.2 and a subnet mask of 255.255.255.0. The interface should be enabled with the no shutdown command. Next, we move on to the serial interface S2 zeroth on router R1, which connects to router R2. We need to configure this interface with an IP address of 192.168.4.1 and a subnet mask of 255.255.255.0. since this interface serves as the DCE end of the connection. We also need to set the clock rate to 64,000 and enable the interface with no shutdown. The configurations for F0, 0th, and S2, 0th on router R1 have been completed. Now, let's take a look at the configuration for router R2. We need to configure its S2, 0th interface with an IP address of 192.168.4.2 and a subnet mask of 255.255.255.0. Since this interface is not used for clocking, there's no need to configure the clock rate. We can enable the interface with no shutdown. Next, we configure the interface F0, 0th on router R2, which connects to the PC. The IP address for this interface is set as 192.168.2.1 with a subnet mask of 255.255.255.0. This address will serve as the default gateway for the PC connected to this interface. After completing the interface configurations on the devices, we can proceed to configure the IP addresses for the PCS. First, let's configure PC0. Its IP address is 192.168.1.2 with a subnet mask of 255.255.255.0, and the default gateway is 192.168.1.1. Now, let's move on to PC1. Its IP address is 192.168.2.2 with a subnet mask of 255.255.255.0, and the default gateway is 192.168.2.1. Great. All our basic configurations are complete. However, we forgot to configure the host names for R1 and R2. Let's do that now. The host name for R1 is R1, and the host name for R2 is R2. Next, we want to enable communication between our two PCS, as we discussed in the previous lesson. Since they are in different subnets, we need to enable a routing protocol between the three devices. We will use the RIP protocol for this purpose. The configuration for RIP involves two steps. First, we enable the RIP process, and then we announce the directly connected networks. In our case, the directly connected networks are 1.0 and 3.0 subnets. So, we need to configure the RIP process with the following commands: router RIP and then network 192.168.1.0 and network 192.168.3.0. Okay. In the previous lesson, we discussed that if there are no subnet details involved, there is no need to configure the V2 version of the RIP protocol. However, if there are non-contiguous subnets, then we need to configure the V2 version of the RIP protocol between the routing devices. To enable the V2 version, we use the version 2 command. Alright. This is the configuration for the S3560 3-layer switch. Now, let's proceed with the configuration of the routers. For the router's configuration, it is the same. How do we configure its RIP protocol? We use the command router. Right. Then, we announce the directly connected networks. It is connected to two networks. One is 3.0, and the other is 4.0. Right. So it is network 192.168.3.0 and network 192.168.4.0. Similarly, if needed, you can specify all networks. But in our case, we don't need to enable them because there are no discontiguous subnets or subnet information configured on this router. If I change it to 172.16.1.2 here and 172.16.2.2 there, then there will be subnet information. And this subnet information is separated from other networks. In this case, we need to enable version 2. The command to enable version 2 is simply version 2. OK. Now that we have completed the configuration of the router R1, let's move on to the configuration of router R2. First, we enter the router configuration mode by typing router RIP. Then, we declare the directly connected networks to be advertised to other routers. We use the network command followed by the network addresses. In this case, we have two networks, 192.168.2.0 and 192.168.4.0. So, we use the commands network 192.168.2.0 and network 192.168.4.0 to declare these networks. We can now observe their routing tables to check if they have learned the routes from each other. Now that we have finished configuring the VLAN interface SIP addresses, we need to add the corresponding interfaces to their respective LANs. To do this, we first enter the interface configuration mode for interface F010 by typing interface F010 and use the switchport access command to add it to VLAN 20. With the interfaces added to their respective LANs, we can now proceed to configure the IP addresses for router R1.